Welcome to The Explainer. Today, we're prying open the scientist's toolkit. We're going to look at the two fundamental ways we make sense of the world, either by just carefully watching it or by actively jumping in and putting our ideas to the test.
So, have you ever wondered how we get from a simple moment of curiosity, just noticing something, to a real, solid, evidence-backed answer? It's that journey from, that's weird, to, aha, now I get it.
Well, to answer any question, a scientist has to pick the right tool for the job. So let's start by taking a peek inside that toolkit.
At the very heart of all scientific research, it really boils down to two core strategies. You can either stand back and just watch the world as it is, or you can get your hands dirty and actively test a specific idea. These two methods are what we call systematic observation and controlled experiments, and they're the foundation for everything we're going to talk about.
First up, let's dive into the method that so often kicks off the whole discovery process, the simple, powerful art of watching.
So, what do we mean by systematic observation? Well, it's basically the process of studying things out in the wild, in their natural environment, without interfering at all. Think about an astronomer tracking a planet, or a biologist watching a bird build its nest. The golden rule here is look, but don't touch.
And you can do this yourself. It's actually pretty simple. Imagine you've got a plant on your windowsill. If you start counting its leaves every day, measuring its height once a week, and maybe jotting down how much sun it gets, well, you're doing systematic observation. You're not changing a thing, you're just collecting data, looking for patterns to emerge over time.
And that's really the power of this method. It's absolutely perfect for answering the question, what is happening here? It lets us describe the world with real accuracy and notice connections that might just spark a much deeper question.
But, just knowing what's happening isn't always enough. We're curious creatures. We want to know why. And to get that answer, we need a totally different tool. This brings us to the power of testing.
Okay, let's go back to our little plant. So after a few weeks of just watching it, we've noticed it's growing pretty well. But that sparks a new question. Does the fertilizer we're using actually cause it to grow faster? That one little word, cause, is a game changer. It signals we're shifting from just watching to wanting to test for a reason.
And to find that cause, we need what's called a controlled experiment. Now, this is a method where we test a guess, a hypothesis, by changing only one single thing, what scientists call a variable, while keeping everything else exactly the same. That idea of control, that's the secret sauce. And let me tell you, that control is absolutely crucial. Why? Because if you change the fertilizer and the sunlight and the pot all at once, you'd have no clue what actually made a difference. To get a reliable conclusion, you have to run a fair test, and that means isolating just one variable.
An experiment follows a really clear procedure. First, you form your hypothesis, your testable prediction, like fertilizer improves plant growth. Then you isolate your variable, in this case the fertilizer. Next, and this is key, you use a control group, an identical plant that gets no fertilizer. And finally, you just compare the results.
And here's what that looks like in practice. See? Our control group gets plain old water. The experimental group gets water with fertilizer. But look at everything else. It's identical. Same sun, same pot, same soil. The only thing that's different is the one thing we're testing. Now that is a clean experiment. All right, so we've got our two main tools. Let's put them side by side and really see how they stack up against each other. How does watching compare to testing?
You can really see the differences laid out here. Observation is all about describing patterns in the natural world, where the scientist is just a passive fly on the wall. Experimentation, on the other hand, is for testing a very specific idea, usually in a controlled lab, where the scientist is actively changing something. It all comes down to the big question you're asking. Observation asks, what's going on, while experimentation asks, why is this going on?
There's a great saying that I think just nails it. Observation is for exploring the whole forest. It gives you the big picture. But experimentation, that's for testing a single tree to really understand it inside and out.
So, are these two methods rivals? Does a scientist have to pick a side, team observation versus team experiment? Not at all. In fact, they're really just two sides of the same coin. The reality is, they aren't competing at all. They're partners. They're a complementary pair. And science truly works best when they're used together in this powerful, never-ending cycle.
It all starts here. Observation asks the question.
Just by watching the world around us, we notice something cool, something that makes us curious and that just begs for an explanation.
And that's when experimentation swoops in to find the answer. We take that question that popped up from our observation, and we design a super-focused, controlled test to figure out the cause and effect.
And here is that beautiful cycle in action. You observe a pattern. Hey, some of these plants grow faster than others. That leads to a question. Why is that? So you design an experiment to test a hypothesis. Maybe it's the fertilizer. And the results give you new knowledge, which, of course, just leads to new, smarter observations. And the whole thing starts all over again.
So, the big takeaway here is this. A scientist's toolkit is pretty useless with just one of these tools. To build a truly complete and accurate picture of our world, you absolutely need both the wide-angle lens of observation and the zoom lens of experimentation.
And that leaves me with a final thought for you. What's a pattern you've noticed in your own life? Maybe one route to work always feels faster, or you feel way more productive after your morning coffee. How could you design a simple experiment to actually test if what you've observed is real? Go ahead, think like a scientist. Thanks for joining us for this explainer.